Hello everyone, my name is Priyanshu Bhalodiya. Today I want to bridge the gap between our engineering labs and real world. We often study a Boolean algebra as abstract math, but today we will explore how these simple logic gates are silent and guardian protecting a millions of passengers every single day in a railway signaling system. A foundation of a modern transport safety built on a marriage of digital logics and engineering railway. This page introduces how a Boolean algebra serves a purpose of beyond simple computing. It is a fundamental language used to ensure engineering for safety by treating environmental condition in binary inputs. Engineering can create a system that protects millions of lives through a mathematical certainty. Next, in a world of a railway, every signal acts as a critical decision node. Before a system clears a train to proceed, it must simultaneously verify the specific checklist. The track must be unoccupied, the route must be set correctly, no conflicting movement can be authorized, and all switches must be locked. The real world conditions are treated as a Boolean variables, and rules that combine them are very logic gates we study in class. Next, the AND gate represents the ultimate safety check where a green signal is only issued when every signal safety condition is satisfied simultaneously. Using Boolean expression y equal to a dot b, the system ensures that if one input such as a track clear drops to a low state, the output is immediately forced low, turning the signal red. Simple put, a green light is only possible when both the track is clear and the route is correctly set. Next, OR gate. While AND gate are used to clear a path, OR logic is utilized to detect a fault condition and hazard in safety system. A signal hazard is informed to trigger a protective response. For example, if the track is occupied or a signal failure occurs, a system output a stop command. Similarly, if a speed limit is exists or a brake fault is detected, an OR gate triggers the emergency brake because in safety, in any signal 1 hazard must result in an alarm. Next, NOT gate, the fail safe inverter. A NOT gate is the backbone of a fail safe design, ensuring that a safety map correctly to physical reality. Most sensors are active high for a danger, and meaning a train represent on a track is represented by the logic 1. The NOT gate boolean y equal to a bar inverts the signal so that the presence of danger 1 produces a red signal and output 0. Ensure the system default to a safe state. Next, interlocking is the hardware enforce a logic network that prevents a conflicting train movements, such as two trains enter the same block. This system is so vital that logic gates are often physical or PLC based to ensure no software bug can be override them. It's coordinate several functions that once a route setting, a track vacancy detection, signal authority, conflict prevention, speed enforcement, and emergency stop. Next, a track circuit and logic at a railway level. This page explains how we get a binary signal from a physical environment using a track circuit. By sending a low voltage current through a rail, a train metal axle can short the circuit, changing the logic state from 1 to 0. This creates a binary signal that feeds directly into the AND or OR gate networking without require a complex software layer and providing a robust and immediate logic input. Next, a real base Boolean equation. In simplified interlocking system, we can see these gates expressed as an actual equation. Signal clearance using a 4 input AND gate where every input must be high for a green light. Conversely, emergency stop trigger used as a 3 input OR gate where any signal fault triggers the break. Finally, root lock verification use an OR gate to detect a fault and NOT gate to invert the result into a safe lock state. Next, from relay to PLC logic evolution. This physical implementation of a logic has evolved significantly, moving from the electromechanical relays in early 19 to solid state transistor circuit in 70s and finally to modern PLC computer interlocking. However, the most important takeaway is that the Boolean operation can are identically across all three generations. Modern system like a Westinghouse microlock now executes millions of these gates. Evolution vary every second. Next, to conclude, a railway signaling remains one of the oldest and most circuit application of a Boolean logic. Remember these four pillars and means all condition must be safe or means or any signal danger trigger protection not provides the fail safe inversion and interlocking representation the physical gate network enforce safety 24/7. Thank you.